Striga is a parasite that infects maize, sorghum, millet, and even rice. A parasite means that it lives off other plants. So what Striga does is that it attaches to roots of these crops, sucks out nutrients, and then kills them. And Striga is a very successful parasite, and the success for the parasite is because it produces a large number of seeds, and these seeds remain in the ground for decades. All crops, maize, millet, sorghum, and all cereal crops are parasitized or attacked by at least one species of Striga. And what it does is that it causes losses of about 20 to 100% yield losses. What that means is that for a farmer, you have lost at the minimum 30% of your yield. So a third of your yields will go, if you're lucky. At the worst, it does a complete yield loss. That means that a farmer will not be able to harvest a single grain from that farm. And then about 40 countries in Africa are infested with Striga. And that means about 50 million hectares of land are infected with Striga. In terms of dollar losses, in rice, Striga causes $200 million in a year. Overall, we estimate this to be about 7 billion losses in crop yields across all hosts of Striga. So enormous economic losses. Farmers, and when I talk about farmers, I talk about smallholder farmers in Kenya. So these farmers have struggled with various ways of controlling Striga, and this would mean that hand weeding, crop rotation, as well as using trap crops. But these are not very efficient because of the large amount of seeds that are in soil. And so we did a screen of wild sorghum accessions from where sorghum and Striga originated from. And we bumped into 3 really good resistant sources. We know through molecular biology the genes that are causing this resistance. And we have a 2-pronged approach. So the first approach is to introduce these genes into farmer-preferred varieties that are already popular with farmers, but are Striga susceptible. And a really good example that we have is Ochuti. So you can do that using a genetic modification approach, and you're already doing that because you already know what the genes are. Or because we know what the genes are and because we know what the source of the gene is, then we're also using a very precise breeding approach called marker-assisted introgression. So from here to a farmer that has to struggle with Striga every year, the 2 approaches that I have mentioned, so the genetic modification versus the marker-assisted, actually there's a third one, will take different times. One that is guaranteed to provide resistant or Striga-resistant sorghum to farmers in the short term, so I'm talking about 3 to 4 years. Then we have a longer term, and then we have a much longer program.